Okay, Saxon 4 math class, we're ready for lesson 82. It's all about a really fun concept called tessellations. And so we are going to take a look at a really cool website called Illuminate, and it's got an interactive part that tells about tessellations. You have to start from a simple shape such as a triangle or a square or a hexagon or rectangle. And what tessellations do is that you can fit them together like a puzzle to where there is no white space showing through. You'll see this in real life in floor tiles or bathroom tiles, things like that, artwork. And it's really fun to do. And you can look and see how these triangles tessellate. Okay, so we call it a tessellation, or creation here. And that was made from triangles. This one they started with, you can see part of the original shape here from the hexagon. And you can see how that all fits together like a beautiful puzzle piece, and you can play with the colors, and it's really beautiful. And there's an interactive part where you can start with either a triangle, a rectangle, or a hexagon. So let's start with a triangle and leave it on edit edges mode, and you can just pull the edges. Make them look really crazy, and then hit tessellate, and you can see how they all fit together. Now let's try one with a rectangle and hit tessellate. Isn't that cool? Let's try hexagon and hit tessellate. You can also play with the information button, and it gives you the area in square units as opposed to the perimeter, and you can see it changes. It's very interesting to do that. The first time I learned about tessellations, we started with perfect squares. Started with a piece of paper that was in a perfect square, and we had to take what they called a nibble from one corner to a corner on the same side. Okay, so the example that I have for you, my nibble with scissors looked like this. Let me get it a little bit closer. And then when I cut it out, it looked like this. So let me close that just a little bit. So this is what my shape looked like. And then I took that nibble out and I slid it to the left and taped it to the opposite side so that it looked like this. And I colored it in. Let's see if it'll let me do that. Ah, it's not. Okay. But now if I select this whole shape, so I have the whole shape selected and grouped, and now I'm going to, let's do some copying and pasting, and you'll be able to see how my shape tessellates. And remember, I started with a perfect square. I took a nibble out of one side with my scissors. I slid that nibble to the opposite side. So you could take a nibble out of the top and slide it to the bottom, or the left and the right, it doesn't matter. So I'll do this a couple more times just because it's fun. And you might want to try it too. So this is a shape that tessellates. Now let's take a look at our examples for today's lesson. We don't have examples for practice, sorry. It says trace this figure on your paper a few times, turning your paper as you trace to show that the figure will fill a flat surface. So if you would take the red trapezoid, you could play around with that, trace it, and turn it different ways and make it all fit together, or make it tessellate. Okay. Now look at B. Does this figure tessellate? It's a pentagon, And if you try that, try fitting it together, no, it does not. Now, the next shape up that has 6 sides does, okay? Here we have our regular hexagon, we have our trapezoid, and we have a parallelogram, also called a rhombus. It says, look at the 3 shapes below. Find pairs of shapes that will tessellate. Make a list to show the combinations of each pair of shapes. So as you do this, if you'll take a yellow hexagon and a red trapezoid, as many of those as you need, and see if you can make them tessellate. Okay? And then try the hexagon with the parallelogram. And then try the trapezoid with the parallelogram, and you will see that all of those combinations do work together. And if you remember playing with pattern blocks a lot when you were in kindergarten and first grade, you will remember making tessellations. Okay, let's go back and check 81 written practice quickly. So hit pause as you check 1 through 6. Hit pause as you check 7 through 14. And hit pause as you check 15 through 30. Okay, now we're going to do some mental math. Now, the trick that we did in yesterday's lesson was with subtraction. And you had to add on to a number and to make one of them end in 0. But that was with subtraction. So today we're back to addition. So let's take a look. Let's make 38 go up 2 to 40. And let's do 46. Let's take it down 2 to 44. So then we have 40 plus 44. 84. Let's take 67 up 3 to 70. Let's take 24 down 3 to 21. So we have 70 plus 21. 91. Let's see, this one's easier to take up this time, I think. Let's take 28 up 2 to 30. And let's go down 2 on this one to 42. So 42 plus 30, 72. Okay. Now we can group these however we want to. I think it's easier to do the 3 times 50 first. I'm really going to look at just 3 times 5, and that's 15, and then tack on 1 0. So right now I have 150 times 10. Okay, so it's really like 15 times 1, but then I have 2 zeros in that problem. Let me show you what I mean. So if I write that problem again, 3 times 50 times 10. I know I can't do all of this at once, so I have to group 2 together. Okay, 3 times 5 is 15. Tack on 1 0. I bring down the rest of this problem, and so I really have 150 times 10, but we're going to look at the digits that are not zeros. So 15 times 1 is 15. I had 2 zeros in the entire problem, so I tacked 2 zeros onto the end. So I have 1,500. Counting by 5s from 5, every number Julio says ends in 0 or 5. If he counts by 5s from 9, then every number he says ends in which digit? Okay, so if we start at 9 and we add on 5, we get 14, right? And then if we're from 14 add on 5, we get 19. So it's a 4 or a 9 is what they end in. Geometry. The radius of the truck tire was 15 inches. The diameter of the truck tire was how many inches? Okay, this is cute. I found a picture of a flat tire, but we can still see radius and diameter. Radius is the point from the center to the outside. Okay? Diameter, however, is all the way across. So it's like twice as big as the radius. Okay? So the question is, if the radius was 15 inches, then what's the diameter? So if this distance here is 15 inches, this one's also going to be 15 inches. And put those together and we have the diameter. So 2 times the radius equals the diameter. So 2 times 15 will give me diameter, and 2 times 15 is 30, and that was in inches. There we we have it. The total cost for 6 boxes of snack bars was $17.70. Round this amount to the nearest dollar and then divide by 6 to estimate the cost per box. So if we round $17.70 to the nearest dollar, is it closer to $17 or $18? It's closer to 18, isn't it? And then we take that 18 and divide it among 6 boxes, so 18 divided by 6. And that would be about $3 per box because 3 times 6 is 18. Okay, calculation, 25% of 40. 25% is the same as saying a fourth. So that means we need to take 40 and divide it by 4, and that would give us 10 times 2 is 20. 20 divided by 10 is 2 times 8 is 16. Plus 59. So I think the 10 goes with the 50, and that's 60. And then add my ones, and we get 75. Okay, problem solving. Landon is packing a lunch for the park. He will take 1 bottle of water, a sandwich, and a fruit. He will choose either a ham sandwich or a peanut butter and jelly sandwich. For the fruit, Landon will choose an apple, an orange, or a banana. Make a tree diagram to find the possible combinations of lunches that Landon can pack. Then list each possible combination. Okay, his only choice for a drink is water, correct? So we're going to put that at the top. That's his only drink. However, for his sandwich, he has a choice between ham or peanut butter and jelly. Now for his fruits, it said apple, orange, or banana, right? Okay. So if he picks ham, he also has a choice of apple, orange, or banana. And if he picks peanut butter and jelly, he also has a choice of apple, orange, and banana. Okay. So here's 3 choices. The ham goes with the water. And here are 3 more choices. So how many different combinations do we have? 6 different combinations. And you could list them all out. But it's obvious that it's water, ham, and apple, water, ham, and orange, water, ham, and banana. That's the first 3 choices. Water, PB&J, and apple, water, PB&J, and orange, or water, PB&J, and banana. Total of 6. Okay, and the last thing that we have to do today is our power up, and your job is to think faster than my pen tablet can function. Okay, here we go. And there you have it. Hopefully you are faster than I am now. And we're finished.